In part A, we determine the position vectors PQ and PR vector. So first, let's determine the position vector PQ. We write the PQ vector, and this equals the point Q minus point P. And so this equals, we replace point Q as 2, 4, 6, minus the point P is 1, 0, minus 1. So here we do the corresponding subtraction of the components. That is, the x component we have to subtract 2 minus 1 is 1, and 4 minus 0 is 4, and 6 minus of minus 1 is, that is 6 plus 1 is 7. And so this is the PQ vector in component form. We can write down this in IJK, that is vector form. So it is 1i, which I write down as I, plus 4j, that is 4j, plus 7k. And so this is the position vector PQ. We now determine the position vector PR vector. So we write PR vector, and this equals the point R minus point P. Let's replace the point R, which is 1, 3, 5, minus the point P is 1, 0, minus 1. So here we do the subtraction of the corresponding components. That is, x component 1 minus 1 is 0, and then y component 3 minus 0 is 3, and then the z component is 5 minus of minus 1, which is 5 plus 1 is 6. And so this is the position vector PR vector. We write down this in vector component form, that is 0i plus 3j plus 6k. This is the position vector PR vector. In part B, we determine the cross product between the vectors PQ and PR vector. So we write down the cross product of the two vectors PQ and PR vector as PQ cross PR. This basically equals the determinant of the vectors PQ and PR vector. So first I write down the IJK components, and then in the second row I write down the components of PQ vector. For PQ vector it is 1, 4 and 7. So it is 1, 4, 7. And in the third row I write down the components of PR vector, that is 0, 3, 6. And so we have to determine this determinant. So let's expand the determinant along the first row. So I write down this first one is I component, and leaving the row represented by I and the column represented by I vector, we get the 2 by 2 determinant, that is 4, 7, 3, 6. Then I write down the next one in the second column, that is this one has to be written as negative j vector, and leaving the row and the column represented by the j vector, we get this 2 by 2 determinant, that is 1, 7, 0, 6. Then I write down this k vector multiplied with leaving the row and the column represented by the k vector, so which gives the 2 by 2 determinant 1, 4 and 0, 3. So let's simplify this. Here we find the product of the diagonal minus the product of the cross diagonal. So we get I vector times 4 times 6 is 24, minus 3 times 7 is 21, minus j vector. Here also we do the product of the diagonal minus the product of the cross diagonal. So 1 times 6 is 6, minus 7 times 0 is 0, plus k vector times we do the product of the diagonal minus the product of the cross diagonal. 1 times 3 is 3, minus 4 times 0 is 3. Let's simplify this. This is 24 minus 21 is 3. So I write down this as 3i, and this is 6 minus 0 is 6. So we have negative g, so it is negative 6g plus 3 minus 0 is 3, so it is 3k. So this is the cross product of the two vectors pq and pr vector. In part C, we determine the area of the triangle PQR using the cross product that we have found in part B. So we write area of triangle PQR. This basically equals half of the magnitude of the cross product of PQ times, that is PQ cross PR, where PQ vector represents this vector and PR vector this vector. So it's basically the cross product of the two adjacent vectors. And so we can write down its magnitude. Half of, we have to find the magnitude of 3i minus 6j plus 3k. So let's find the magnitude of this vector. So this is half of, for magnitude we take square of the sum of the squares of the components, that is 3 squared plus negative 6 squared plus 3 squared. And so this gives a half of 3 squared is 9, negative 6 squared is 36, plus 3 squared is 9. And so this gives, when we add this, we get 9 plus 9 is 18, and 18 plus 36 is 54. So it's basically the square root of 54 divided by 2. And so when you plug this into the calculator, we get approximately 3.67. This is approximately 3.67. And so therefore the area of the triangle PQR is 3.67.